A coil of inductance 300 millihenry and resistance 2 ohms is connected to a source of voltage 2 volt. The current reaches half of its steady state value in how much time? So we have the voltage provided by the source 2 volts is equal to, we have a single element, a single coil that is having an inductance and a resistance. We can assume these to be in series, and therefore 2 volts is the sum of the potential drop across the inductor, which is inductance multiplied by rate of change of current, and the potential difference across a resistor, which is resistance multiplied by the current. So this is equal to 0.3 di by dt plus 2 times I minus 1 is equal to 0. In this expression, if we write x is equal to I minus 1, then we have dx by dt is equal to di by dt. Therefore, the equation just simplifies to 0.3 dx by dt plus 2x is equal to 0. If we rearrange some terms, we get dx by x is equal to 2 by 0.3 into minus dt. And now we can integrate this from t1 to t2 and x1 to x2. And on the left hand side we get the natural logarithm of x2 by x1 is equal to minus 20 by 3 t2 by t2 minus t1. And substituting the values of x1 and x2, we get I2 minus 1 divided by I1 minus 1. The natural logarithm of that is equal to minus 20 by 3 into t2 minus t1. So now if we assume that at time t1 is equal to 0, current is 0, that is the switch is just switched on or the connection is just made at time t is equal to 0. Then we have the natural logarithm of I minus 1 divided by 1, or rather divided by minus 1, is equal to minus 20 by 3 into t. And now taking the exponent on both sides, we get I minus 1 is equal to minus e to the power minus 20 by 3 t, or the current in the circuit is equal to 1 minus e to the power minus 20 by 3 t. Now at time t is equal to 0, the current is 0, and at time t is equal to infinity, the current is equal to 1 ampere. And we have to find out at what time, let's say t0, the current is equal to 0.5 ampere. So what is t0? According to the expression, we have 1 minus e to the power minus 20 by 3 t is equal to 0.5, or e to the power minus 20 by 3 t0 is equal to 1 by 2. Taking the natural logarithm on both sides, we get minus 20 by 3 t0 is equal to the negative logarithm of 2, which is equal to 2.3 into 3 into 0.3 approximately, and we have a negative sign there. So t0 is equal to 2.3 into 0.3 into 3 divided by 20, and this is approximately equal to 10 to the power minus 1, or 0.1 seconds. And hence option A is the answer.